Hello and welcome. We have started a series of lectures on statistical quality control, and we have already discussed the basics of a mean chart and a range chart. Now we are going to cover a very interesting case. In last two lectures we tried to learn how to construct mean chart and range chart from the information about sample means and sample ranges. That means in that case sample means and sample ranges were readily available. Now as I said, we have a very interesting case. In this case we have been given the information about 12 samples from which we need to construct a mean chart and a range chart and draw our conclusion. The information about 10 samples and size of each sample is 5. Common size of each sample is 5. These are the sample points or sample values. Now to construct a mean chart, we must have the means of all the 12 samples. And we know that mean is sigma x upon n. So these are the summations of all the sample values for all the 12 samples. That is the first step towards the solution of this problem. So this is for sigma xi, sigma x1, sigma x2, sigma x3 and so on. And size of all the samples is 5. That means n1 is 5, n2 is 5, n3 is 5 and so on, n12 is also 5. So sigma x divided by n, that is divided by 5, can give us the sample mean. So this is the first step of solution, to have the summation of all sample values for all the samples. Then divide the summation of sample values, that is sigma x, by the common sample size, that is 5 here. So these are now sample means. But we know that to construct a mean chart, we have to find out the upper control limit as well as lower control limit. And to find out the upper control limit and lower control limit, we must have the mean of the ranges. So to construct mean chart, we must have the sample ranges also. What is sample range? The difference between the highest sample value and the lowest sample value is called the range of this sample. So the values are already in ascending order. Highest value minus lowest value, that is the range. Highest value minus lowest value, that is the range. So second step was to calculate sample means. The third step is to find out the sample ranges. So whenever you have been provided with a data of samples, the first step is to find out the samples, summation of all the sample values. Then second step is to find out sample means, and the third step is to find out the sample ranges. That is nothing but the highest value in the sample minus lowest value. In this way we have everything. Now in the first part we are going to construct a mean chart only. And as I have said, to construct a mean chart or our x bar chart, we must have upper control limit as well as lower control limit. But before that, to find out the control limits, first we need to find out the mean of all the means. Mean of all the means, grand mean is also said. Mean of all these means, that is grand mean of all 12 samples is summation of all sample means divided by number of samples. Summation of all sample means came to say 859.2. This is the summation of all these sample values. That is 859.2 divided by number of samples 12. That gives us 71.6. This is the rounded off value in with one decimal. Yes? Okay, so it comes to 71.6. This becomes our central line wherever we construct the mean chart. Okay, now we have grand mean, so we can now calculate UCL as well as LCL, lower control limit, upper control limit. First we are going to calculate upper control limit. What is the formula of upper control limit? Grand mean plus A2 R bar. How to calculate A2 is out of the scope of this chapter. So value of A2 can be derived or rather can be found readily from the table. In the last two lectures I had all say discussed how to find out the value of A2. So I am not going to repeat it. Just keep the table handy. In the first column, find out the sample size of 5, and in the same row, you can find out the value of A2, that is 0.577 for sample size 5. The formula grand mean plus A2 0.577 into R bar. For this purpose, we need range and mean of all the ranges, even when we want to construct the mean chart. So ultimately, it gives us the upper control limit 106. Again, this is rounded off value. Central line is nothing, it is grand mean 71.6, and lower control limit is also very easy. It is grand mean minus A2 R bar. See, upper control limit is grand mean plus A2 R bar, lower control limit is grand mean minus A2 R bar. So, if we make any mistake in calculating the value of A2 R bar here, I think that will be actually repeated here also, and the values of both the control limits might be wrong. So be careful. Lower control limit comes to 37.2. Yes, this is also rounded off up to 1 decimal value. So now we have all the three things. So we can go for drawing or constructing a mean chart. But before going to the graph paper, let me clarify that I am going to draw the sketch only, because on board it is possible to draw only a sketch. You please keep your graph book or graph paper ready. Now, first of all, what is the highest value we need to plot on the graph paper? Upper control limit is 106, but check the mean value, sample means it is 112.4. So on the graph paper we need to show this point, plot this point. So it is necessary to draw the chart, particularly the vertical axis, to include 112.4. Similarly, what is the lowest value? Lowest value here in control limit is 37.2, but one sample mean is even lower than that, 33.4. So 33.4 should also be included on the graph on vertical axis. So on vertical axis we need the minimum value 33.4 and maximum value 112.4. By rounding off, we can say that we must start the vertical, rather values on the vertical axis with 30, and it must go up to 150. Then only we can include both of these extreme points. And whoever have studied the first lecture on SQC, mean chart, carefully, they can understand that this is even less than, this sample mean is less than lower control limit. That means this is, say, below the lower control limit. Similarly, this is greater than the upper control limit. So this will be upper side of the upper control limit. So just on the basis of our observation of these values, upper control limit, lower control limit and sample means, we can observe that one sample mean is less than or below the lower control limit, one sample mean is greater than or above the upper control limit. That means we can conclude that the process is not under control. In examination, a paper setter may also ask the question in this way. He or she can tell you to write or draw your conclusion just on the basis of the control limits and sample points. So be careful at the time of reading and understanding the question from the question paper. Draw the control chart only if you are asked to draw or construct the control chart. Paper setters are actually mostly rather very clever. They use the word very cleverly. They can ask the question in a way that calculate the control limits of mean chart and draw your conclusion or state your conclusion. That means you have not been asked to draw or to construct the mean chart. Then don't draw it. Just on the basis of this much information, you can write your observation, you can write your conclusion. But here, of course, we are going to draw or construct the mean chart. Yes. Okay, I will have to abolish so many things from here. Let me try. To draw with abolishing minimum possible things. If necessary, I will rub a few lines from this much information. Yes, on vertical. Okay, chart always starts from 0, so we need to pull the vertical limit. Yes, this is called pulling. 0, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115. Okay. Sorry, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115. Okay, highest value we have taken is 115, so that we can plot 112.4. Okay, now these are sample means. On the horizontal axis, we need to take the sample number, only 12 values. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11 and 12. These are sample numbers. Okay, very easy. First of all, we need to draw the 3 lines. Upper control limit, central line and lower control limit. First of all, central line, and what is the grand mean? Grand mean, I have already written it with me, that is 71.6. 71.6 can be taken here somewhere. Central line 71.6, this is nothing, grand mean, x double bar. Okay, upper control limit is 106 and 106 can be taken here somewhere. And mind well, remember we show the upper and lower control limits with dotted lines. Upper control limit of x bar, yes, it is 106, the rounded off value. 1 millimeter equals to 1 decimal place. That's why I prefer to round off everything with 1 decimal place value only. Yes, lower control limit is 37.2. 37.22 can be taken here somewhere, and this is lower control limit, so it is shown through dotted line. Lower control limit of mean 37.2. Okay, now just 12 sample means. Sample number and sample mean are treated as coordinates. On horizontal axis sample number and on vertical axis sample mean. The first sample mean is 69.4. Okay, sample number 1 value is 69.4. It comes here somewhere below 70. Yes, you can place the dot between the last millimeter after 65 and 70. Now I leave this to you. Okay, sample number 2, the sample mean is 63.4. 63.4 somewhere here between 60 and 65. After 3 decimal above the value 60. Third is 57. 57, 2 millimeters above 55. Okay. Yes. Then 4, sample number 4, 64. 64 means 1 millimeter below 65. Sample number 5, it is 57.4. 57.4 again. Yes, it is second time. Okay, 57.4. The other one was 57. So slightly above 57. Sample number 6, and it is 82. Sample number 6, 82. 82 means 2 millimeters above 80. Here. Yes. Again, this is just a sketch of the graph. You will be able to draw the accurate graph on your graph paper. Yes, sample number 785. 85. Sample number 8, 33.4, the lowest value. 33 means 3 millimeters above 30, and that means it will be in the fourth box of 4th millimeter. 8, sorry. Sample number 9, 46. 46 means 1 millimeter above 45. Sample number 10. Mean is 112.4, the highest value, 112.4. For this purpose, we went up to 115 on the vertical axis. Sample number 11, 93.6, 93. That means 3 millimeters above 90 is 93. So it will be between, rather inside the fourth box of the 4th millimeter, but above 90. And the last 12, it is 95.6, 95, and immediately in the first box, because 1 millimeter after 95 is 96, so in the first box itself. So on your graph paper, the mean chart will look something like this. We are interested more now at this point of time, at the time of observing. We are interested more in these 2 points. Here our observation. First observation is related to upper control limit. What is our observation? This one sample point is above the UCL. Just on the basis of this, it has been proved that the process is not under control. But we must observe the situation relevant to the LCL also. Number 2, lower control limit. What happens with the lower control limit? Again, one sample point is below the LCL. Even any one of these two happens, the conclusion remains the same. The process is not under control. But always observe the chart in all its references. How many points are above UCL, how many points are below LCL. Be specific and then only arrive at the conclusion. So now we can write the conclusion. The process is not rather under control. Yes, either the process is under control. When can we conclude that the process is under control? If, only if rather, all the sample points are within the 2 control limits, UCL and LCL, then only we can conclude that the process is under control. At least one sample point is either below the LCL or above the UCL, we conclude that the process is not under control. So, this was the easiest possible explanation of a mean chart on the basis of the sample data. Somewhat lengthier, but in many examinations I have seen that paper setters prefer to ask this kind of question. Okay, this is time consuming, but we have no other way. My role is to simplify the thing. Yes, okay, I tried my level best. I hope this lecture is useful to all of you to understand how to construct a mean chart from the sample data. Okay, don't forget to like this lecture. If any of you have not still subscribed my YouTube channel, PRASHANTPUAR, don't forget to subscribe. Please suggest, recommend my channel, my lectures to all your friends, all your junior and senior friends. Thank you very much.